Hello viewers, welcome back to my channel, Massa Tutorials. We see where mathematical literacy begins. All right, so today we are celebrating Easter. So this is my is it Lamborghini? It's a Lamborghini as well. Yeah. hmm hmm So let's see. I'm here again to solve elective stroke further mathematics for my dear WASI candidate. That's roadmap to WASI 2026. And today I intended to treat calculus. Calculus. That's it deals with derivatives and what integrals of functions. So we have a nice problem here. That's evaluate the following definite integrals. So when you talk of definite integrals, we have what? Limits. That's the bounds. We have the limits or the bounds given. Indefinite integrals, there are no what? Limits or there are no bounds. That's the upper bound. This is the upper bound, and this one is the lower bound. We can also call it the upper limit and the lower limit. Then this is the integrand. So we want to integrate this function with respect to x. With respect to x. So integrate from the lower limit 0 to the upper limit pi by 6 of this function cos x square root of 1 minus 2 sine x with respect to x, which is the x. Very, very simple question. Yeah. You sip small, you solve small. Like I said, mathematics is not a spectator of sports. So kindly please study hard and harder. In fact, hardest. Okay. Yeah, invited. So we go. How can we solve this integration question? So solution. Here we can do by the use substitution or using the substitution approach. So we can say that a variable should represent 1 minus 2 sine x. So let's say let u equals 1 minus 2 sine x. And if u is equal to 1 minus 2 sine x, don't forget the method we are using. We are using u substitution, okay? We are using the u substitution. You solve small, you sip small. We go. So du dx, which is equal to, so we have to differentiate this expression we have here. Now, when you differentiate a constant, you get 0 minus this one, 2 is multiplying sine x. We can just factor 2 out. Then we differentiate sine x. When you factor 2 out and differentiate sine x, you will get cos x. Then you differentiate the angle. And when you differentiate the angle, x, when you differentiate it, you get 1. So 1 times that is still 2 cos x. So we write du dx is equal to 0 minus 2 cos x is negative 2 cos x. Now, we want to take away this dx. So we make the x the subject here. By making the x the subject, you can see that the x will come to this place, then negative 2 cos x will come to this place. When you make the x the subject, that's what you get. So you get the x is equal to, that's 1 over negative 2 cos x du. The x equals 1 over negative 2 cos x du. So we go. So now we have integral from 0 to pi by 6 times so open bracket, we have cos x square root of 1 minus 2 sine x. We said u, let u represent that, so it is just u. Then we multiply it by, what is the x? The x is this expression, that's negative 1 over 2 cos x. Then du. We are differentiating, so we are integrating with respect to u. Cos x will cancel cos x. Don't forget. So this guy and this guy away. So we get integral from 0 to pi on 6. Then we'll get square root of u times negative 1 over 2 du. So I'll be cleaning the top so that I'll get more space to solve. All right. But lest I forget, since we let u to be equal to 1 minus 2 sine x, you can decide to also change the limits, because the limit given is for x, not for u, because you are getting with respect to u. So take note, the limit given is for x. So if you want the limit for u, you have to substitute the upper bound, which is pi by 6, inside this expression, 1 minus 2 sine pi by 6, so that it will give you then the u2 as well. That's 0. So x is 0, you substitute, then you get the upper bound for that. Don't forget, pi by 6, we are doing that in radians. It is in radians, pi by 6. It is in radians. So the angles are in radians. The angles are in radians. But if you don't want to use the limits, you don't want to change the limit, then you can maintain the x limit. When you are done, make sure that you made u to represent 1 minus 2 sine x. You bring it back. That's all. Very simple. You bring it back. But if you want to change the limit, then first you put in the upper limit, and after that you put in the lower limit. When you are done, you compute the upper bound for u, then also the lower bound for u. If you don't understand, please play back the video for better understanding. You solve small, you sip small. Lamborghini. For us, we will not use the u limit. We'll still use the x limit. So when I'm done, I just put it in back. So let's integrate that. Now check, we are integrating with respect to u. So negative 1 over 2 will come out. So negative 1 over 2 come out. Then we have the integral 0 to pi by 6 square root of u du. And don't forget, square root of u can be written as u exponent 1/2. And with integration, we add 1, then we divide by what? The total power. So we get negative 1/2 integral. Okay, so I'm coming to integrate. So let me bring this. So u exponent 1/2 plus 1 all over 1/2 plus 1. Then let's see 0 to pi by 6. It's not difficult. So negative 1 over 2. So we'll get u exponent 1/2 plus 1, that's 3/2 all over 3/2, then 0 to pi by 6. Don't forget the limits are for x, not for u. So we can't just substitute. Now this one is 1. So 1 divided by 3/2. 1 divided by 3/2. It will change. That will have the reciprocal, and that will be negative 1 over 2 times 2 out of 3. Then we have u exponent 3/2. Then that will be 0 to pi by 6. Okay, so let's see something like this. Now, 3/2 is the same thing as 3 times 1/2. And 1/2 represents what? Square root. Okay, 1/2 represents square root. So we can write it as negative 1/2 times 2 out of 3. Then square root of what? U, that's the half, that's square root. Then exponent 3. Then 0 to pi by 6. So that's what we have. Okay, so now let's substitute in u. Don't forget u represent what? 1 minus 2 sine x. So 1 minus 2 sine x. Let me write it somewhere here. So somewhere here. So I'll get negative 1/2 times, that's to test. It can cancel out. This one can cancel. So you get negative 1/3. So let me do it negative 1/3. This one can cancel. So you get negative 1/3 times, okay, let me bring my square root of u. U is 1 minus 2 sine x. Then we bring our limits, which is 0 to pi by 6. 0 to pi by 6. So now I'm coming to substitute in the what? The x values. So the upper limit and the lower limit. So here we have negative 1 over 3 times the square root of 1 minus 2 sine x. Then our limit is 0 to pi by 6. Now let's substitute. We'll get negative 1/3 square root of, we substitute 1 minus 2 sine, that's x is pi by 6, minus the same thing, negative 1 over 3 times the square root of 1 minus 2 sine. Our x is 0. So this is what we have. Let me clean this side. It's very, very simple. Mathematics is not a spectator sport. You solve small, you sip small. It is finished. It is my best drink. Mhm. We go. Now, don't forget the angle is in radians, so we have to change our calculator settings to radians. So, um, we press shift and mode setup, shift plus mode setup. Now, 3 is degrees, 4 is radians, so we press on 4. You see that on top of the calculator. I call it, is it the title bar? Yeah. Then we have written what? R over there. So we can punch, let me punch the whole of this on it. Then let's, so square root of 1 minus 2 sine, that's pi. Oh, sorry. That's pi negative 1 over 3 times square root of 1 minus 2 sine my fraction pi on 6. I close the bracket. Here I get 0. When you point the whole of this on the calculator, we get 0. Minus, I point the whole of this on the calculator also. Because I've punched it first on the calculator, I just change the pi by 6 to 0. So 0. So I'll get negative 1/3. I get negative 1/3. So when you punch this on a calculator, you get negative 1/3. And we have negative. Again, we get pop. So 0 plus 1/3 is just 1/3. So we can say that therefore, integral from 0 to pi by 6 of cos x times square root of 1 minus 2 sine x dx is just equal to 1/3. All right. So that's it. Mathematics shouldn't stress you. No. It shouldn't stress you at all. You play with mathematics. Just be playing around it. No, it's not difficult. I promise. It's not difficult. Mathematics is very simple. So please and please do out and all right. So mathematics is not difficult, like I said. Make sure you practice more examples. This is elective stroke further mathematics roadmap to WASI 2026 calculus. If you don't understand, play back the video for better understanding. See you in our next video. Bye bye.